Hi, welcome to my talk on build games faster using automation. I'm Kieran Statch. I'm a lead developer, creative person, all around whatnot to a few dragons. By day, I'm a software developer, and if you've ever played Among Us with me, I am always the sus person and get voted out first round. So today we're going to be talking about continuous delivery or continuous integration. What is that? It's a sort of series of pipelines, softwares, behaviors, ways of us doing things that enable us to make software in an automated way. So letting computers, servers, and other things make and build our programs, deploy them for us. Whether that be games or software, in today's talk, we're going to be aiming that at games. But for the most part, it's that series of steps that allow us to get a machine to do what we would normally do on our own computers. Why would we do this? We can make it work faster. So for the build part, it's going to be relatively the same speed, but once we get into doing multiple builds on multiple platforms, on multiple different machines, we can make it work faster. If we have builds that take up to a few hours long, you don't want to lock up your machine doing that either. So it's really good to start using the cloud to do this kind of thing. Once we get a perfect pipeline or build running, we can repeat that. The computer can repeat that with the exact same steps and be much more reliable than us. We're likely to forget things. We're likely to mess things up. So reliability is a really big kind of feature or a thing that we want to achieve by putting these systems in place. And one of the better things that I like to think, because it really helps our players, is we can deploy and build more often because we're allowing other systems to do this for us instead of getting caught up with I don't feel like it, I don't have the time to do it, we need to work on these other bugs so we don't have time to do builds. So letting the other things do it, we can do that daily, we can do that a few times a day, it just works out better. So I'm going to take you through what my kind of findings with what I've gained as benefits for my game, The Sacred Acorn. I like to build quite often. The reason for this is I use Unity. I found that when I test in engine, sometimes things don't work the same as when you build. So I want to build and then test using like what a player would be using. I feel that that's just the best way of testing. So here we've got 1 week of me doing builds, Monday to Friday. I try not to work weekends. You shouldn't either. We've got approximately 2 hours of builds. This is me just building on Windows. Roughly 15 minutes a build for a Windows build for my game. That's doing it on the cloud. If I build on my PC, it takes about 10 minutes, not 15. The cloud computers don't have as much dedicated resources as my machine, but they're also not locking up my machine. So just take these numbers with a bit of, I guess, well, it looks like I'm saving two hours. I'm probably only saving 1.5 hours of my actual computer time. But at the same time, I am, especially if you don't have as good of a computer, you probably are saving that exact time. Like if it takes the cloud to do the same amount of time as your development PC, then you are going to save the same amount of time. It's going to vary depending on what your circumstances are. So anyway, for 1 week on a Windows build, we are saving 2 hours. Let's put that up to 1 month. We're saving approximately 8 hours. So after 1 month, let's say your computer was locked up during build. I know with many engines, while you're doing a build, you can't be developing at the same time. So we've gotten back 1 whole day, 1 work day of time. At least that's for my game. I know again, there are other games that take up much longer times to build. So getting that time back is really good. Let's head up to 1 year. So for our Windows build here, we're saving approximately 100 hours. That's almost 2 full work weeks of time that we've used just building so we can test or do other things. I think this is already a great example of where the benefits come in. And I think any producer looking at this is going to be like, yep, that's a lot of time. I definitely want to get that back for my people. What I will say is, you seem like you're getting 100 hours back, but still take your breaks. Like, don't think that, oh, I can get that time back and I have to put 100% of that back in. This is a great way of getting a bit of time back to give yourself a bit of space as well. Just something to think about. Self-care is important. I'm sure we've all run into this before, but I really feel that this is kind of one of the main, this meme is one of the main drivers of why I love automation so much. Is we've all been at a workplace where, at least us coders, where we've been told, like, hey, what are you doing? Like, you're not doing work. You're like, oh, my code's compiling. And they're like, fair enough. And they just leave you to it. No one questions it because everyone knows how long code compiling or building can take. And I think that's really funny and just shows how much time we've wasted that it's become a meme. So I was saying that this was just on Windows, at least that those numbers were. We can build to multiple platforms. So that could be Windows, Mac, Linux, Switch, Xbox. You can do things like Android, iPhone. You can do online platforms like Stadia. They will require their own build. There's plenty of other different things. If you're on Windows, you have to do a different one if you're doing the UWP, like the Windows Store, versus if you're doing a native Windows build. So all those different things are going to take up time. A lot of engines will require different binaries for those. If you're making a game in Python or RenPy or something that doesn't get compiled down to the native source code, you can just do one build and you don't have to save all this time because you're already saving time. But for things like Unreal and Unity, it is most likely that you're going to be building a different binary for your game for each different platform. I know for us, our Windows build takes about 15 minutes. Our Mac build takes 19. This is on average. And our Linux build takes 17. So let's go down to what a multi-platform week will look like. Before we're saving 2 hours. Now we're saving about 7 hours. So I've just fixed a bug. I want to test that on each of the platforms, making sure it's right. I especially want to test it if, let's say I'm only getting a bug on Linux. There's just a weird thing where my tile sets aren't loading or something. What is really good is we can build that, but we don't want to just test Linux. We want to be like, all right, we've fixed this on Linux, but have we broken it for Windows and Mac? We've got to check that. So I'm still going to be building every time I'm fixing, even for one platform bugs. So we've gone from 2 hours to 7 hours. Let's look at it for 1 month. So for 1 month, we've gone up to 27 hours. So we're starting to save quite a bit of time. We were 8 hours, and now we've gone to 27. That's quite a big jump. So for 1 month, we can save 27 hours, or at least for my build. 1 year, we've gone to 368 hours, approximately. So as you can imagine, and this is just for PC, you start putting in consoles, that's going to take a long time. What's good about the PC here is that the amount of time I'm saving is just based on I can build and then straight away run that on my machine. If you're testing Xbox or PlayStation, you're building, then you've got to put it onto the console or the Switch or phones. There's a deployment phase there for each testing round. You can automate that so it goes directly to those accounts and those places that you need to do. So automation is going to really save you on those types of platforms. It's going to make you feel like you don't hate yourself. I've definitely seen people that, you know, I've done this myself before I got into automating everything, is, you know, you, especially for when I was doing some phone development, you fix your bugs, you run your Xcode build, you have to deploy it to your iPad or whatever. That takes so much time. It's such a hassle and it's such a process that we just don't need to do. And I think we shouldn't, because there's a better way around it. Caveats of doing builds. As I said before, most of the time, building on your actual machine will be a bit faster than the cloud environment. That being said, I can only do one build at a time on my machine, whereas the cloud environment can do all platforms at once. If you've got multiple agents, and I'll go into that a bit later, but let's say I've got my 15-minute Windows build, my 17-minute Linux, and my 19-minute Mac. So that's going to take my computer about 50 minutes to get done. It's going to take the cloud 19 minutes because it's only going to take as long as the longest build, because it does all three at the same time. So while, yes, even if my computer's doing it a bit shorter, let's say 10 minutes of build, that's still half an hour compared to the 19 minutes. So either way you look at it, unless you are doing a one platform build, like it's going to save you so much time. And the headache of switching environments around on your local PC, doing different configs, you can just write all that into it and it'll do it every time. The other small issue, at least with what I found, when you're doing cloud builds, if something does go wrong, it sometimes can be a bit harder to find out what the issue is. So it takes a bit longer to go through the logs and stuff. Whereas if you're building on your PC, at least for me, that error comes up straight away and you can debug that straight away. But if you've got a pretty solid pipeline for these builds, that's going to not happen too much. The only bugs that will probably happen is in your actual game, which regardless of doing it on your PC or the cloud, you're not going to find out till you play it. So that's not too big of an issue. So I mentioned deploying before. We've got lots of different places to deploy. Some of these require different builds. So I know for us, we are currently doing Steam and itch. What that means is we have to put into our builds some special Steam stuff so we can get the achievements, cloud saves, other little things, workshop items. Those things require a special part of the program to be put into our builds for Steam. We don't need those on itch, and we don't want them either. We can't just put the Steam build on itch because it's going to fail when the DRM kicks in, or the game tries to post an achievement that it doesn't have access to, and it's going to fail. So for our Windows, Mac, and Linux build, we now have Windows, Mac, and Linux on Steam, and Windows, Mac, and Linux on itch. Sorry. Get my throat a bit caught there. What is good about this is we've got 6 builds now, and we can get our cloud service to do all that at once rather than our computer doing the 6 different builds and then we have to deploy it. What you are really saving here is that deploying time. So once you build up your thing, you need to package it. That packaging is a bit of a manual process on your PC. You have to zip it up, put the files in what you need, rename them how you're meant to. You might have to do a config file. That takes so much time manually. Your cloud service is going to do that in like under a minute and then deploy it to Steam or deploy it to itch or deploy it to Discord. So we use Discord for our test people. So we give them a role on Discord and we can upload the game to Discord because it has services for that for people that aren't aware. It's really good. Just a side note that you can do that, and I recommend it's a really good way to do that, especially if you like testing with your community and such. But yeah, we can save lots of time. The little bit of a caveat here is that Steam requires a manual process even with the automation. So once the build is uploaded to Steam, which is the most hardest part. You just have to go on Steam and say, yep, this build is the one I want to go live to my players. Then they'll get that straight away. Another little note is not all platforms are going to work with auto deployments, and I can't tell you which ones they are. There's so many platforms that you can publish your games to now, whether it be Epic, GOG, Steam, Xbox, PlayStation, Stadia, Luna, your different stores on mobile now. On Android, you've got different stores like the Epic Store, the Samsung Store, the Google Store itself. There's so many different things. So your mileage may vary, but hopefully you can automate most of those and take out a lot of the time. So like I was saying before, I was spending 1 year, about 100 hours for the Windows version. And just with deployments to Steam and Itch, we're going from 100 hours to 115. So that's 15 hours of cloud doing deployments. That would have taken me a lot longer than 15 hours, I can tell you. It is a grueling process uploading something to Steam. Itch isn't so bad. But yeah, to any developers who are still doing it manually, I think you know how hard those deployments can be and how happy you would be with yourself if you didn't have to do them. So now that we've gone through all the data, you're probably wondering like, oh, I could probably still do it. To my answer to that is like, people aren't perfect. Even if you think, oh, it's a bit faster, I can do it, I don't need to set up the time, you're not going to get the process right every time. You're going to mistype things. You're going to deploy the wrong things. I have worked at places where something was built and someone deployed the wrong version. So tell the customers, hey, these new features are live, but they're not because one of the devs uploaded the wrong build. Like they uploaded the build that was already up there, or an older build, taking things away. These things happen. If you program your pipelines right, these things are going to happen a lot less. So it is very worth it. I can't stress that enough. I've seen like people make a build and they spent so long trying to get the build right, they forgot to deploy it live on the actual servers. So many different things can go happen. And like the old saying goes, if something can go wrong, it will go wrong. And building and deploying is no exception to that rule. So I will go through my pipeline example, but just to note that I think it's very important that you work out if this is right for you. It can be a very time-consuming process setting up automation, but I think it's very worth it. So for most of my projects, I probably spend 2 or 3 days getting the automation working, and a lot of people are going to feel like, hey, I'd rather be making my game, not setting up this thing. And it's going to feel like that at times. Your 8th hour in, you're going to be like, is this worth it? And I promise you it's going to be. Once you've gotten that set up, like it just feels really good that at any point I can just tell my cloud service, hey, build my games. It takes 1 minute and I don't have to worry about anything else. And I can get back to programming a bug or a new feature or something. It's really good. So let's talk about my example. We just launched probably about, since this is pre-recorded, I think it's like a month and a half ago now, our game Lightsmith. I'm just going to quickly go through what the pipeline for that looks like. So we use GitHub for our source control. Every time we commit to main on GitHub, our pipeline detects that and says, hey, there's a new commit on main, let's go through the pipeline. And this is what our pipeline looks like. So first we check our Unity license. Is that valid? It is? Cool. If it's not, we do an extra step, which is request a new activation file before we do the builds. With our builds, you can see that we've got our each build first, or each matrix, and our Steam matrix. This matrix is essentially we've got Windows, Mac, Linux for itch, Windows, Mac, Linux for Steam. So let's just go through how easy it is to sort of set this up, kind of what it looks like, at least doing it for GitHub. Lots of things are going to be a little bit similar to this, like the code or the definitions will be different, whether you're using like Amazon pipelines or GitLab deploys. Things like that they're gonna be different in sort of how you set it up, but the kind of points, the overall achievement and goals you're trying to do are going to be the same. So let's get into it. First job we have in my GitHub Actions is the check license. So all this is doing is every time we commit to main, the first thing it does is check, hey, is our license valid to be building with Unity? It's very simple. It checks whether it uses a action to check, hey, runs this little program. Is this license valid? Checks with the Unity server. Yes. If it is, it runs that and outputs a true or false. From there, it goes to our next one, which is that activation step that was skipped, as you saw last time. If the result of check license is false, we're going to run this step. This step will get a manual license file. It will run that. It'll generate its artifact that it needs to. It then puts that into a GitHub secret, so other parts of the pipeline can use that. And it's going to run that against an action that someone else has made, but I am using, called web attacking, which I think they've now renamed to GameCI. Once activation is done, we're going to go through build Steam. This is the step that we do for building Steam. It is a matrix. And as you can see, we've got a matrix target platform. So things to note here. We do not want fail fast on. If fail fast is on, if any of these fail, it's going to stop the whole process. We don't want that. We want at least all of them to build, especially for Steam, because it'll deploy it, but it won't deploy it live to players. We still have to do that manual step, remember. And so if Windows and Linux pass, but OS X fails, which I have had happen before, I can make sure those builds are ready, and then I can only build OS X next time by putting in a commit message like --OS X. What that means is it'll just be faster next time. But yeah, I don't want them all to fail if one does. So we've got our matrix target platform. The target platforms are standalone OS X, Windows 64, Linux 64. Now that we've got our matrix set up for our, this is for our Steam build, we're going to go through the steps. So we're going to check out our code from main. This is what's happening on the cloud server. We're going to cache any library files. So this makes, if I'm only doing one bug, let's say I change a few sprites, let's say I change a few textures, caching all the build files, let's say all of our binaries that we build haven't changed. It's not going to have to build those again if we cache them. So if we just need to update a sprite or something, we can get our 15-minute build down to 7 or so minutes, because all it needs to really do is package everything up again. It's just changing a few things. So the bigger your deltas between your builds, the more less of the cache it's going to use, essentially. So using a cache is really good. And we just store that each cache against the target platform. So it's going to say library. It's going to replace that matrix target platform with standalone OS X or standalone Windows. Here comes the main part. Again, using Unity, we're going to build our Unity game using the Unity builder. We're going to specify the version. We're going to specify the target platform that we want, specify where we're going to. We have some custom parameters here. So this is a production build. So strip out all the debug stuff that I use locally. We have another custom parameter. This is what I was saying before, that this is a Steam build. Steam needs that extra stuff, or those extra binaries to build achievements, cloud saves, all those other things that I was talking about before. This is where we do it. So we don't have to run 2 separate build steps. We just need to say, for these builds, put this option on, which is the -steam. Once we have done that, we upload the artifact. So if we want to download these manually, I make sure to upload them. What we do next, we generate our Steam code. We generate, so as you know, Steam is fun and requires a MFA code. So we've got something that generates that for us. And then we go to our Steam deploy. We get our username, our password, and that code that we stored. These are all stored in secrets. So what's good about this is I can generate all this, put it in the GitHub secrets repository, and no one else on the team or anyone I don't want to can't view those. So they can just say, I need the secret to make this build, but they can't actually get that Steam username and password and log into my Steam account. Not our company's Steam account. We actually make a separate account just for builds for security reasons. And I suggest anyone doing this does that too. That way we have, if that gets compromised, none of the store pages gets compromised. So for Steam, you can upload a build, but you can't, like with that account, you can upload a build, but you can't change any of the store information, which is very good. Like, it would suck if someone uploaded a build with a virus or something, but it would suck more if someone uploaded a build with a virus and changed all our store images and store information, or disabled the game or took it down. So just giving yourself an extra layer of security is good. And these secrets and using a different account is one of them. So we do a build description, going further a bit. And that's just, I usually just do the version. So 0.1.7. And that's all of it is, really. We deploy it to a location ready to move up. And we deploy that to Steam. So itch is going to be exactly the same. I did forget to mention before that this step needs the check license step. So if check license passes, we do this step. So this is set to true, whereas the activation is set to false. We build for the name is, we're using that target platform again. So we're doing the same thing. We have the matrix running on Mac, Linux, and Windows. So we've got the fail fast again. We've got the same target platforms. Let's head into it. We're going to be doing a lot of the same stuff. So we're going to be caching for that target platform. We're going to be checking out our code. We're going to be running Unity Builder. What you'll notice here this time, though, is we've got the same version. We've got the same target platform. We've got the same build names, build paths. But we don't have that Steam custom parameter. So these builds are going to be slightly different with their binaries than our Steam build was. And that's what's going to get deployed to itch. This is really good, so we don't have all those errors I was talking about earlier. We're not going to have our itch builds trying to contact achievements when certain things happen and fail because and possibly crash our program because you don't have Steam open, or the person owns it on itch but doesn't own it on Steam. These little things require a different binary. So it's good that we can do this in an automated way. The difference here is we're going to be uploading to itch, not Steam. So we use a different deploy action in GitHub. This is an itch publish one. Again, we use a API key, but we keep it in secrets. So whoever has access to that, it can put it in GitHub, and everyone else in the team or people that we don't want can't see that. And it really narrows that security down to only the people who absolutely need to get into the account can. The rest of this thing is going to be the same though. So we've got the itch username. So that's just the page that we're deploying it to, which is a few dragons for us. Our game ID, Lightsmith. The channel that we're doing it to, which is going to be our target platform, which was Windows, Mac, or Linux. And our build number, which is just our build version. And that's output from our previous step. So that is the nuts and bolts of a deploy and or automation build, going through building it, getting the code, and deploying it to your platforms. I think you can already see this can get really big if you're doing 9 platforms to 15 storefronts. But you can also see that if you are doing that many things, it is going to feel great having all that done by a computer and not you. And you not spending a week of your time getting all that stuff ready, making sure you press all the buttons at once. So I think it's really good. I hope that people look into this. Feel free to ask me questions afterwards or during. And we'll go on to the next steps or extra things that we can do now. I do have a little bit of a story actually before, which is I was watching someone on Twitch and they were developing their game on Twitch, and I think it came out probably a week beforehand. They were doing some bug fixes and they were putting language files in, taking things out, doing what they needed to do to get the build ready. And I wrote in chat like, oh, you could use an automation process. Like you could like not worry about doing this. And he was doing it live as well, which I don't recommend. And he's like, no, I trust like myself more than like getting all that stuff sorted out. Like this is a reliable process for me. So he goes through it all, spends a lot of time talking with people. Also, like making a build go live while talking to chat takes a lot of time. So what happens is he does his build live. People are talking in chat. They're like, hey, there's no words, there's no language in this build. He realized he forgot to put the language stuff in, so he had to go through another 20-minute process of rebuilding everything. So he was using this on Unreal. This can happen in any engine though. And I didn't say anything, but I was just looking at like, you know, everyone can tell themselves that they're going to do it perfect every time, but it's just not possible. We are human. Treat ourselves as human. Don't put that pressure on ourselves, and this won't happen to you. So we're going to go into another section that I haven't even covered with everything else. So test automation. This is where I think automation gets really cool. So I don't do any of this in Lightsmith just yet, but in the Sacred Acorn, every time we do a build, it tests that you can get from every area that you are meant to the next area and back. It's a game about exploration. I want to make sure that works. It takes a lot of time to go through those areas manually, playing it ourselves on every platform. It takes very little time for my automation to run up run up the build 17 times in 17 different platforms and test like, all right, can we get from area 1 to 2? Can we get from area 1 to 4? Can we get from area 4 to 3? It does all that really quickly and gives it a pass or fail. If any of that fails, the build doesn't go live on Steam, doesn't go live on itch. Furthermore, we just want to test core stuff here. So you could spend a lot of time making sure this stuff, all your core stuff works, and that's what we really want to do. I don't think the time that you spend making these automated tests is going to be worth testing every little minute different pathway that you can go. But testing your core things, like I said, like going from area to area, that's a big part of an exploration game, is going to be worthwhile. As we mentioned, you can stop the builds going live as well. The other thing that we test is our game is about exploration. There's a bit of combat as well. So with the combat, we just test that if the main character is told to do an attack and there is an enemy, so we have a player, it moves to the right, it uses an attack action, does the enemy's health go down? We put a listener on that in our test. If the health is going down, then cool. The core parts that make up the movement, the attacking, and the health all seem to work, because for that test to pass, we know that those three things must be working. Sure, there might be an attack that's range has been moved down, that fails, but the core part of it we know works. And that's what we really want to test. It's going to save you a lot of time. Other automation that we can do. So I hope everyone has a website for their game or their studio. We can set up CI for that as well. So at A Few Dragons, we have a self-hosted website using Lightsail on Amazon. This is really good. It has a database and everything built into it. And we make a custom Laravel website that allows us just to do a few cool things that we like doing. And we can set up. If you're using WordPress or something like that, it's probably not going to be that big a deal for you. There's other services that do this for you as well. I can't name them off the top of my head, but I'll be in chat and I'll have got that list for you now. But there's ones that I think one's called Webflow, but they do this automation process for you where you design and build the things and you just push it to their services and they'll have this pre-set up for you. Anyway, it's good. I can just, let's say there's a new feature that like, our game used to be an exploration combat game, but now it's an exploration colony sim combat game. I want to update our website. I can just put that word in. I push it to our dev branch. It goes up on the dev website. I check it. I'm like, hey, that's cool. Then I push it to our main branch and it goes live at afewdragons.com. And I'm like, oh, cool. Now our game is also a colony sim. I recommend making a game a colony sim before saying it is one. The other really cool sort of automation we can do is game servers. So, and the testing goes into this a lot as well. Game servers might need to be deployed in many different regions. If you're a worldwide game, it might need to be deployed to several machines. If you've got like hundreds of thousands of players, one machine's not going to cut that. You don't want to do that process manually, and I don't imagine anyone is, but if anyone is a small indie looking to get into this space, I think it's a very good idea to look at that redundancy of having servers around the world and multiple of them. You could do that manually. As you can see though, the numbers that we were showing before, that's going to take a long time. You can make an automation for that. The other thing that we can do is before we deploy those servers, we can make sure that like, hey, our game has 20 people. Build that, and we're going to test, we're going to run up 20 clients, connect to that one server. Hey, does everything work? Did the win condition work? Do the lose conditions work? All that's going to be really easy with automation, and it's just something that should be really good for you to sort of look into. Another thing that we can do with all this build stuff and all this automation stuff is notifications and whatnot. So things build, things fail, things succeed, whatever it is, you might want to be notified about that. Not always by email. So we set it up by email, but you can do it into Slack, into Google Chat, into Discord, whatever kind of your process is. Your team can get notified. You can even go so much further, saying like, in your commit logs, putting the change notes, and then when your build is done, it posts those change logs to a dev log you have, Facebook, Twitter, whatever it is. You might prefer to do that manually. That is one thing that I don't think automation is going to get super right. There's going to be, you might want to post differently, or how you post you experiment with, or you want to put a lot more feeling into it. Then, marketing isn't something that I suggest you automate. So where can you get all this stuff? I think that's going to be a talk on its own. But some of the ones that I think are really good, GitHub, GitLab, JetBrain, Atlassian. If you want to go more in depth and really customize your approach, I do recommend Amazon pipelines. I find they're really good and really in depth. Azure's deployment is really good as well. I personally haven't used Google Cloud, at least not in my day job, or I think I used it a little bit for an API I made once back in the day, but all those are going to offer these really powerful solutions. Again, like, you're going to need source code for this as well. I haven't really covered that in this talk because it wasn't the point. I hope everyone's already using source code to back up their project. So all these resources will have source code as well, and you're going to need that to trigger your deployments. For those using Unity, there's actually a Unity build service that they're offering now. I did use it once. I found it was a little bit restricting, but it's something that you can look into if you're using Unity and Unity Teams specifically. It also provides the source code thing that I was talking about before. You can also do all of this. You don't have to be using Git for your source. I know there's a few other things out there, like I think it's Perforce is one. You'll be able to do this kind of stuff with all of those. So just it's going to be what your situation is and what service you want to use is going to really depend on the money you have is one. Some of these services are free. GitHub and GitLab have great free offerings. Your build process is going to depend on what you want to use. So there's things out there like Jenkins, there's the GitHub Actions, there's Amazon's Code Build. Yeah, there's a lot out there. I say do your research based on your competencies, based on your money and allowances. Again, thank you so much for listening. I'm going to be sticking around in chat. It's weird to say. I guess I'm talking to myself now because I'll be in chat and I'm listening to myself. I'll be around for the next 10 minutes. I hope you stick around. I hope you have some cool questions. I love talking about this stuff. So again, thanks and enjoy GCAP.